Ratios and similar polygons, section 7.2. So we're going to continue talking about ratios along with proportions. And now we're going to talk about some similar polygons. All right. Who remembers what a polygon means? Poly has the what term? Poly means many or multiple. Nice job. So we're talking about polygons or multiple sides or many sides. Polygons. Similar polygons. Similar polygons are polygons that have the same shape, but not necessarily the same size. All right. Which geometric shape is always similar? A square. Nice job. Which other geometric shape that is not a polygon is always similar as well? Circle. Okay. Squares and circles are always similar. The difference is a square is a polygon, whereas a circle is not. Okay. Similar polygons. Corresponding angles are congruent. So corresponding angles are the same. Recognize they are denoted as such. They're just denoted that they're the same. Okay, so in order to be similar, the angles have to be the same. The sides have to be proportional. Now, proportional means is they have the same ratio. So, for example, AB is like twice of DE. AC is twice DF. And BC would be twice EF. Or you could say half if you wanted to go the other way. You know, EF is half of BC. But it has a ratio. All of them would have to be the same in order to be similar. If one of them is different, they are not similar then. A similarity ratio is the ratio of the lengths of the corresponding sides. So for the similarity statement, ABC is similar. Notice similar uses the squiggle mark to triangle DEF. The similarity ratio is 2. For triangle DEF is similar to triangle ABC. The similarity ratio is 1 to 2. So it kind of depends which way you go. Now make sure you recognize, it's 1 to 2. 2 to 1. Make sure you put the correct ratio part with the correct triangle. Match them up in the order they're given. That is important. So let's look at number 1 here. I want to identify the pairs of congruent angles and congruent sides. So for instance here, I have angle J. What is angle J going to be the same as, Caitlin? How'd you know that, Caitlin? Yeah, if you look right there, they have the same congruency symbols, so they would be the same. What about angle L? What's angle L going to be the same as? Angle what, Jersey? Angle what? P. Again, they have the congruency symbols. Then that leaves me with what, Drew? Angle K is the same as angle... How do you know that, sir? Has to be 180. So the other two are the same. Then third angles have to be the same. Nice job, sir. Now we have to do the sides. So what is JL going to be the same as? If I look right here at JL, or sorry, not the congruent, it'd be similar. What would JL be similar to? Again, JL is right here. JL would be similar to what, Peyton? MP. How'd you figure that out? Yeah, look at the congruent parts there. Okay. J goes with M, L goes with P. Well, then JL is the same as MP, or similar to MP. What about LK? What would LK be similar to, Austin? PN. And lastly, what about KJ? So KJ would be the same as NM. All right, try number 2 now. Take a couple seconds, try number 2 on your own. All right, let's look at these. What about angle A? Angle A, Hannah, what's that going to be the same as? Angle Q, nice job. Angle B, Trevor. Angle C, Bryce.
Angle S.
Angle D, Johnny.
T.
What about AB? What's AB going to be similar to, Tyler? What'd you say?
RQ.
RQ. What about BC? What's BC similar to, Ryan? Good. What about CD, Anna? And what about DA, Tom? Nice job. So again, that's the similar parts there. The corresponding parts, angles, and sides. Now number 3, determine whether the polygons are similar. If so, write the similarity ratio and a similarity statement. Okay. So let's look at the angles. What do you notice about the angles? What's F the same as? Yeah, angle F is congruent to angle J. That's great because they're both 101. What else do I know about the angles? What about angle G, Mats? Angle G is the same as? Well, if I have 2 angles the same, are the third angles the same then? Yes. What's angle E going to be the same as? Angle H. So I have all the angles the same. Great. Well, let's look at my side lengths now. What would EF be the similar to? If I were to write a ratio, EF is similar to which other side? HJ. Nice job. So EF to HJ is 10 over 15. Well, what's the ratio of those sides then? 2/3. Well, let's do another one here. Let's try another one. What about FG? What's FG going to be similar to? JK. So FG over JK equals 12 over 18, which comes out to be 2/3. Well, if those are both 2/3, let's do the other one. Let's try EG over HK. EG over HK comes out to be 17 over 25. Ooh, spell that. 17 over 25.5. Does anybody know what that actually simplifies to? Take a guess. It is 2/3 actually. So my similarity ratio would be 2 to 3. Ooh, I put 2. So my similarity ratio is 2 to 3. Huh? Statement would be that EFG is similar to HJK. Yep. All right. Right now about number 4, rectangles. What do I notice about all the angles for a rectangle? All the angles in a rectangle are always going to be 90. So do I have to do anything with the angles? No. I just do the ratio. PQRST to UVWX. So what would RQ be similar to? Not, oh yeah, sorry. It'd be the same as VU, but it's also the same as XW because it's a rectangle, right? So I have 5 over 15 equals, what's the second part that's going to equal then, Caitlin? Oh, no, sorry. What's 5 over 15 equal? What's that fraction? 1/3. What's my other ratio then? 8 over 24. What's that ratio simplified to? So my similarity ratio is 1 to 3. There's my ratio. Good work. Now we can use similarity ratios and proportions to solve for the missing parts. Now what's important about this is to make sure you match up congruencies. So for instance, DE would be the same as like HJ. So recognize DE is the same as HJ. Do not just try and match them up and say, oh, 40 and 18 are both on top, so they have to be the same. Make sure you look at how the rectangles and triangles are facing. So we set up a proportion, and then as soon as we set proportion, we can use cross products and solve for a missing side. Okay, so we can use cross products to do this. So number 5, a rectangle is 3.2 centimeters wide. So I have a rectangle here. It's 3.2 centimeters wide and 8 centimeters long. A similar rectangle is 5 centimeters long. What is the width of the second rectangle? Well, give me a proportion you would use to set this up. Camden, what proportion could you use to set this up? That would work. 3.2 over 8 equals x over 5. Did anybody else set up a different ratio? You could set up a couple different ones. But then once I set that up, what can I use to solve this? Cross products. Use cross products to solve that real fast. Say 4.
This one would be 2/3. So that would be
Not the same. Tyler, did you get it? Austin? X does equal 2. Now think about that. Would that make sense? Yes. Right? The length is smaller, so the width should be smaller. Would an answer of, let's say, like 7 make sense here? No. Or again, think about that. When you're going through these problems, think about what would make sense to the problem. Now the next one's kind of interesting. Rectangle CDEF is similar to rectangle GHJK. And the similarity ratio of CDEF to GHJK is 1 to 16. So that's like saying 1 to 16. That's my ratio. So CDF is like, if that were 1, GHJK would be 16. So if DE is 20, I need to find what HK would be. Okay. So I need to find, I think I have that wrong. I think I should say HJ. That should say HJ. So if DE is 20, I need to find what HJ is. Well, I can set up a proportion. 1 over 16 equals 20 over x. Now recognize, because DE came from the small side, that's why I put 20 on top. Okay, it's kind of important how you set it up. Then, when you work it out, what does x come out to be? Kaylin, what'd you have? Or I should say HJ, I guess. HJ is 320. Nice job. HJ is 320. Good work. All right, take a couple seconds to try number 7 and 8 here. All right, it says ABC is similar to DEF. What is EF? Now, they give you more information than you need on number 7. You just need to set up one proportion. So find similarities and set it up. All right, Bryce, give me the proportion you use for number 7.
12 over 19.2 equals 15 over x.
And then you use cross products and get x to equal?
24.
24. Nice job. What about number 8? What proportion did you use for number 8, Austin?
18.6 over 12 equals 12.5 over x.
18.6 over 12 equals 12.5 over x?
Yeah.
That would work. Nice job, sir. And then when you worked it out, you got what?
8.1.
Nice job. When you work it out, you actually get like 8.06, but nice job of recognizing. It says x to the nearest tenth, so we do round it to the nearest tenth. Good work. Yeah, so we can use ratios to solve a lot of missing angles or sides and everything. Number 9, triangle MNP, and similar to triangle QRS. It gives you the similarity ratio. Try numbers 9 and 10. So let's look at number 9 here. Jersey, which proportion would you set up? How would you set up the proportion? Ryan? Nice job. 42 over x equals 5 over 2. The ratio says it's 5 to 2, so I'm going to use that. And then 5 correlates to MN, so QR would correlate to 2. So then 42 over x equals 5 over 2. When we work it out, then what did you get, Ryan? Nice job, sir. 10. Triangle HJK has side lengths 21, 17, and 25. The two shortest sides of triangle WXY have lengths 48.3 and 39.1. If triangle HJK is similar to triangle WXY, what is the length of the third side of triangle WXY? How would that one be set up, Jack? What do you say? That would work, sir. Nice job. And would you get me worked it out? Nice job, sir. That is correct. Now, if you think about that, would that answer make sense to this problem? Yeah. 48.3 and 39.1 are the smaller sides. That answer does make sense. If I had an answer like 45, would that make sense to what the problem said then? No. So always make sure you go back and check. Does it make sense? Here's your assignment.